Hello everyone, I'm Vivek Kannadi talking from Science Media Center, ISER Pune, and we have with us Jidnyasa and Manasi. Jidnyasa from Bangalore, I'm right, no? From Pune, okay. Jidnyasa from Pune and Manasi from US. And in the background we have Imayavan as camera person, and we have Sujiprata and Anurag in the background taking care of the all technical things. And this particular workshop is made available to us through the program, the project on training program enabling science communication by DST and NCSTC, and Science Media Center ISER Pune is hosting the program. And I would request Anurag. He's also taking care of the technicality in the background. He's going to introduce the guests for today.
Thank you, Vivek. Hello friends, welcome to the webinar on basics of scientific communication skills. To share more insights on this topic, we have Dr. Jidnyasa Mulekar and Dr. Manasi Apte. Jidnyasa Mulekar, Dr. Jidnyasa Mulekar obtained her PhD degree from University of Texas in Austin in cell molecular biology. She worked as a medical writer with Tata Consultancy Services for 3 years. She is currently working with Cactus Communications as a scientific writer. She has experience with writing clinical documents for regulatory authorities, narratives, scientific literature, as well as abstracts, posters, along with manuscripts for publication. We also have Dr. Manasi Apte. Mansi is a researcher at National Cancer Center, Washington, D.C. She received her PhD from Wayne State University in Detroit uh, in, the, in the field of Drosophila and genetics. And now she is working in the field of DNA repair and genome stability as a part of her postdoctoral research. She is also a microbiologist by training with bachelor's and master's degree from India. Along with standing interest and expertise in various forms of science communication, outreach, and education, she has won multiple awards with her skills in public speaking and scientific presentation. She firmly believes that key to communication between scientists and general public is to tell stories effectively, and thus scientists should also receive formal training on communication. So that was a short introduction of our speakers. Without further ado, let's get started with the webinar.
Thank you, Vivek and Anurag, for the introductions. We are both very glad to have this opportunity to present to such a wide community. And I'm going to share my screen. Just let me know when you start seeing it.
Yes, Manasi, it is getting loaded.
Can you all see the screen?
Yes, Manasi, we can see you.
Yes, we can.
Let's get started with today's webinar for the next 2 hours. What we will do is we'll go through, both Manasi and I will go through our, then we will have some Q&A session so far for later, and you can probably write down in the comment section and we'll get back to you during the Q&A session. So when we think of scientific communication, we should always think of the 3 C's: correct, concise, and clear. So whatever data you are presenting, they should be correct, scientifically sound. You should be brief in presenting the data, and it should be unambiguous. There should be no doubt regarding the meaning of your sentence or your paragraph. It should be clear. And we communicate through written documents as well as visual and oral. So I will be talking about the written scientific communication skills, and Manasi will take you through the oral and visual scientific communication. So as you can see here, there are various documents where we store or share our data. And of these, we will talk about the lab notebook, emails, and research articles, the original research articles, but this time we will not talk about the dissertation. It's a bit limited input, but we'll see maybe some other time we can talk. So starting with good documentation practice, and I'm going to start with a small story. So this I heard from my chemist friend, and he said there was a graduate student working in a chemistry lab, and he was trying to get a reaction to work. So he had all the reactions in the flask, and he was trying to make a particular product out of it. So he was trying to standardize the reaction. So he had multiple flasks with all the reactions, different concentrations, permutation combinations of the reactants, and different temperatures. He was going to heat up each flask and then leave it overnight and see if there was a product. So all these multiple flasks he arranged and carried out the reaction. And the next day he came and checked that one of the flasks actually had the product that he desired. He was very happy. Yay, things worked, yeah, for a change. So then he went back, checked what was the combination, concentrations, reaction conditions, and repeated that. That time nothing happened, no product. So he was very curious. He was like, what went wrong? And he was a very good graduate student. So what he had done is he had kept a good logbook. He went back and checked his original experiment. And what he found is when he was setting up the reactions that day, that flask thermometer that he had put in had broken, and he had to change that thermometer. Unfortunately, being a good grad student, he had noted that down. That got his thinking going, and then he realized that, oh, so when the thermometer broke, the lid from the thermometer went into the reaction mixture, and that acted as a catalyst to get the reaction going. And that is how we figured out how the reaction is working. So, if you ask me from this story, I would say that the major breakthroughs in sciences don't really happen on your lab bench or in the flask or when you're running RT-PCR. They happen when you write down your results. They happen when you are recording your data in your lab journal. So if you do bunch of experiments and never record your data properly, you're not going to find out that aha moment in your research. So the first and foremost important thing is to maintain a good lab journal. Now I have listed a few things that are essential. So it should be a hardbound book. So
Jidnyasa?
Yeah.
Sorry to interrupt, but people are not being able to listen to you properly. So maybe speak up a little bit.
Okay, but you guys can hear me well.
It's breaking a bit, so the voice is not very clear. So maybe keep your headphones very near to mouth.
Better now?
There is a little bit of echo. Try it again.
Is it better?
Yes. Yeah, this is better.
Okay. So for a good art journal, it should be a hardbound book. Don't use spiral bound copies. It should be numbered. Whatever you're entering in your lab journal should be legible. And whenever you enter in data, make sure you have dates entered along with it. These days, we all store our data electronically, be figures, be the PCR data, or any other observations where you want to make graphs or Western blot. So data safety is another key point. So you should at least have your data stored at 2 different locations, back up often, and keep it up to date. It's a nightmare when you're trying to write your dissertation and your hard drive crashes and you have no backup. So you don't want to be in that situation. The third point is about planning the experiment well in advance. So whenever you are doing an experiment, you are trying to generate data. And if you are able to plan your experiment in such a way that your data will be a finalized version. Say you are trying to get a Western blot, and if you have all your lanes marked very well when you are planning the experiment, then if your Western blot works, then you have a publication ready figure. So planning your data is also key for the written scientific communication. So it's going to make your life much easier when you have your data in finalized and in publication ready to go. So as and when you get the data, don't wait till the last minute. As and when you are getting your any data in values, try to put them in graphs, in figures. If you have any figures, have them Photoshop, labeled correctly for scale, etc. And keep them publication ready. Will be a very useful resource for your career. The other form of communication is emails. We write emails all the time. We share knowledge over emails. We ask for a paper, some vectors, some seeds, some cell lines to other researchers in our field. And so email communication is also a key form of written communication. Not add the receiver's email address in the two fields until you have finalized your email. So there is no outbound mistake. Always have a subject line here so that the other person knows what you are asking for just by reading the subject line. If it is urgent, put the word urgent colon and then put your subject. When you are addressing, use the title only before the family name or last name, not before the first name. So not Dr. Tom, Dr. Pooch. Hello or dear Dr. Pooch are acceptable salutations. Never write long emails. When you are writing emails, use short paragraphs or bullets. In the very first paragraph, you should introduce yourself and the purpose of why you are writing the email. And then if you are, say, asking for a paper, it's always a good idea to give the PubMed link to the paper, because the scientist may have multiple publications and may not recollect what you're exactly asking. If you are attaching anything, make sure it has been labeled typed properly. Attaching figure 1 does not help what the other person is going to know from figure 1. Especially if you're writing it for the first time with the person, make sure you are labeling your attachment properly. Include the contact information in your signature. Make sure you have your full address, phone number, etc. if they want to reach out to you. And the important thing that I've marked apps and in red font is to read your email before sending. And my trick, we sometimes are blinded by our own writing. So what I do is I draft the email, go to some other work, spend some 10-15 minutes, come back, and then read my email again. And if I find there is no error, then then only I send it out. So that way you are avoiding any errors in your draft and not sending out an incomplete email. Moving on. So when you sit down to write a manuscript, there are multiple steps that can be beforehand that will help you in writing your paper. And for this preparation time, the first thing you need is literature. So what I have listed here are commonly used databases, and except PubMed, rest of them are subscription-based. You need a paid account to access these. And these databases, what they do is they index all the published articles as per the keyword so that they can be searched later. And when you're performing literature searches, your search key is very important, and we'll go a little bit more detail into how you can perform literature searches on PubMed. So here are two screenshots that I've used, that I've put from PubMed. So what PubMed does to index its articles is something called as an acronym for medical subject headings. And if you use these terms, your search will be very much more effective than just using a regular term. So I have also put a link here how you can find out the mesh term and how you can build your search string using these. And you can definitely go and check that out. So all the links that we are sharing in our presentation, we will be sharing those in the description later of the YouTube video later. And you will also get an email with that attachment on your registered email. So don't worry about jotting down the email, the website address. So now when you perform the search, say you have 200 searches, and you don't have time to go through all these results at once. So what you can do on PubMed is save your search results in different forms. You can see on the right hand side, you can save it in Excel format or on a note, and then copy it onto Word, and then go through them later when you have time. So also, PubMed gives you a very good facility to set up email alerts for specific topics of your interest. And as and when any article is published that's indexed under that topic, you will get notified. And you can choose the frequency. Now, I have not put in Google Scholar here. All of us use it very extensively, but that's not a database. That's a search engine. And it has a particular use. It is very useful, but the best use is when these databases index the articles, there is usually a lag of say 7 to 10 days between when the article is published or it's available online and when it appears in these databases. Whereas Google Scholar being a search engine, it picks up the article as soon as it is published. So if you're looking for the most recent article that's published on a topic, then conducting a Google Scholar search is a good idea. So that's when Google Scholar comes very, very handy. But it may not be yet in PubMed or Focus, but it is. You can find it in Google Scholar search. And Google Scholar searches are also dependent on searching. So using the Boolean operators like and or searching that with normal Google work there as well. The other key step that you can do beforehand, before you sit down to write your paper, is create your own reference library. And I have listed here 3 different referencing software. EndNote is a paid software, but Mendeley and Zotero are freeware. And if you have not checked these out, then I would urge you all to go and explore both of these or all 3 of these. And what you essentially do with these is the citations library for whatever references or articles that you can potentially cite as a reference in your magazine. And once you have your library ready, when you sit down to write a paper, it's very easy to insert citations for those particular articles. I have also linked a video for Zotero on how to use that plugin. All these softwares have Microsoft Word plugins that you can install and use them when you're writing your paper. So that is something you can do prior to even thinking of getting starting to write your paper, because this is a continuous process. New articles will come that are of relevance, so you can search them, um, download the citations in the reference library, and keep it handy.
Jidnyasa, sorry,
Yeah.
the audio is again it got reduced. Could you talk louder or keep the mic a little closer?
I think I am pretty close to the mic.
Okay, sorry. Yeah, I think it is better now.
Yeah.
Manasi, how is it? It's audible there?
Maybe what I'll do is do you want to keep my video on?
No, it can be there. No issues.
Okay.
Jidnyasa, maybe talk a little bit slower because some of the words are getting missed. So people are not following exactly how things are going.
Okay. So when you have a full text article, is a key publication as a background research for your article, for your paper. Uh, you can whenever you are reading it, you can go ahead and annotate it for highlighting the important finding or statement. Also follow a naming pattern for your full text articles. Usually you can save them as first author, then the journal abbreviation, and the year of publication. And you can add, if something has a protocol that's important to you, you can add underscore protocol for DNA extraction. That way, when you are looking for where to find your reference, this way, if you have labeled your files, it comes very handy. So now, if you are thinking of getting or publishing a research article, then the first thing you should go for is selecting a proper journal. And I have listed a few criteria here that can be used for selecting the journal. Impact factor is one where it's an index for how many times the articles published in that particular journal are cited overall. And the higher the impact factor, the better the outreach of that journal. You can also choose, depending on the target audience, frequency of issues, though I have listed as a factor, it no longer holds true because most of the articles are published online instantly. The other important criteria could be whether it's an open access journal or subscription only. So with open access, you are able to reach out to a wider audience. And of course, the cost of publishing, what is the article processing charge for any article in that journal. These are the criteria to consider when you're selecting your target journal. And once you have your target journal, make sure to read all the author instructions very, very carefully. Because if you are writing a draft and there is a word limit, you should know it beforehand than later. Now we come to developing the manuscript, which is a typical manuscript of INRAD format. As you know, INRAD stands for Introduction, Methods, Results, and Discussion. But as these appear in the format, the order of development is not the same. So we'll talk about each of these sections in the manuscript in a bit more detail and see what all entails in each of these sections. The first and probably the easiest section to write is method. So if you have performed all the experiments, you know how you did that, right? But the method is critical in the sense that whatever you are writing as method, it should be a reproducible content. So if somebody reads the method section, they should be able to replicate the experiment. Yet it should be brief. You should not write a very long method section. You can divide it into subsections depending on the depending on your own field. So if you are doing some transgenic work, then generation of mutant lines could be a subsection. Then if you are performing any assays, then those could be other subsections of your method section. Usually, the method section is written in past, consistent past tense throughout your this section, not jump tenses. Many a times we use a product or a resource that's from a company, and say for an antibody or a kit that you have used to perform an assay. So make sure you are giving those details wherever possible and necessary. If you are using any protocol, any methodology that's previously published, development published, then do cite a reference to that. And last point is do not include any result. So, for example, you are screening for bacterial species that produce amylase in a particular area of land. So, how you screen for the amylase producing bacteria is part of method, but how many species you screen and or how many samples you screened and how many species you got is part of result. So make sure you are making that distinction while including by writing your method section. Moving to the next result section, it's the most critical component of any manuscript because that is the new that you are trying to convey. The result section should have an inherent sequence or flow. It should be like telling a story. And I know that when we work in lab, when we perform our experiments, we may not use or we may not work in the same order as we would like our results to be told as a story. If you may first screen for the phenotype and then look for the protein levels, but when you are trying to write the results, you should write that these lines were selected based on the protein levels and then you give these bunch of experiments. So maintain that inherent sequence of logic or flow when you're writing the result. Also, if you're not performing any statistical tests, don't use the word significant when you're describing the result. You can use numerically higher, lower, equivalent, etc. But significant means statistically significant. The tables and figures, make sure you have read the author instructions on the number of tables, if there is any restriction on that, and for each journal guideline. And these are standalone parts. What I mean by standalone is if I pick up table from a paper, I should be able to interpret what is given in that table without looking at the main paper. So if there are any abbreviations, if there are any footnotes, if there are any statistical p-value tests, whatever they are done, they should be available or mentioned in that figure or table itself. And when you are citing the tables and figures, you can write only the key results in the text. Since you have the entire table, there is no point in repeating that those same numbers in the text again. And make sure you are citing all the tables and figures that you are putting in the result section. Now comes the introduction. So introduction, why you write later after you develop the results is because introduction is for introducing your result. So once you have the results written or finalized, then only it's a good idea to start with introduction section. And in this, usually you start with identifying the need or what is the question that you're trying to, a broader question that you're trying to answer. And that follows by a very brief literature overview, what is in the field, and that ends with what is the current knowledge gap. So this is what we know, and this is what we don't know. And that don't know is what you are trying to gain or give insight into through your research. Whenever you are writing the literature overview, always cite the primary source. Unless you are saying some very, very established fact in the field, in that case, you can use a recent comprehensive review article for that as a reference. Also, again, bold letters, always paraphrase, do not copy paste, not even from your papers, the papers published from your lab beforehand. That is plagiarism. Even if it's your own paper, it's self plagiarism. And the journals have very sophisticated software to catch plagiarism. You just don't want to get into all that. Write your own sentences, paraphrase, write simply, and it's not that hard. Never ever copy paste. And in the very last section of introduction, you are going to introduce your result. What is the objective of your research? What have you done in this paper? Or what are you presenting in this paper? And that introduction isn't a very big portion of the paper, but it should hold the reader and it should make the reader curious to read more. It should be written in the crisp manner possible. Then, in the order of development comes the discussion, and here what you're trying to do is you're trying to relate your results with the knowledge that's available or out there in the field. We are comparing the results with previous studies, stating whether they coincide, they're in line, or they tell a different story. You're trying to extrapolate your data a bit and come to some conclusion. So you don't need to repeat the results in the discussion. It could be just a brief summary of what was done and the key findings. And then you can keep the same sequence as in the results section when you are discussing each of them. So if you have put in the results section figure A, B, C, then you should discuss figure A, B, and C in the same order in the discussion section. This is also the section where you can discuss the strengths and limitations of your study and also include the conclusions and future directions that could address the new gaps that are found by your research. So make sure your conclusions are realistic. Once you have all these sections close to finalized, then is the time to write the abstract. And abstract is a very, again, it's a standalone document. So make sure when the reader is reading the abstract, they should not feel lost. So define abbreviations, terms that are unfamiliar in the first instance. And abstract should prompt the reader to read the full text. At the same time, if the reader doesn't have much time, it should convey the key message of your research. So usually there is a word limit, so you should follow that very strictly. 250 words, 300 words, whatever is the word limit. Again, going back, read the author instructions carefully so you are aware of these limits. And you don't need to convey all the findings that are in the results section. You can just talk about the key findings in the abstract, and the reader can go and check the rest of the results. And there is no discussion per se included in the abstract. Whenever there is a conclusion, make sure it is a realistic conclusion. those overstate or over glorified conclusions. The other components of a manuscript, the references, we already talked about creating reference libraries. So these libraries also allow you to insert the references that are already styled as per the journal style guidelines. So it comes very handy. If there is any supplementary figure tables that should be also appropriately cited in the message, don't have a supplementary material that's not cited in your message. In the acknowledgements, you are going to thank anybody who has supported the research or writing, editing of the manuscript and has been a part of the research and is not an author. Make sure you take a permission from the person whose name you are going to include in the acknowledgement section. The other important document is cover letter. It's a letter to the editor, and there what you usually state is the key findings of your paper, and then how the paper fits or is a good fit for the target journal audience. So it could be based on the subject matter, could be based on the audience that readership of that journal. Conflict of interest forms are usually needed to be submitted along with your manuscript. There you have to declare any funding that you have received for the research, for carrying out the research that you are presenting. Now, when we look at all these components, you never go to the final draft. There are multiple drafts that you work with, and I would suggest to save all your drafts, whatever changes you're making. Make sure you version them. Say I usually say draft 1, 1.1, 1.2. But the draft 0, the very basic starting point, usually could be in bulleted form, where you're just putting down what you want to be the content of that section. And it's good to start adding references early on than scrambling and looking for a reference later. Make sure you get the proper input from all your co-authors. If it's good if they review the draft time to time. And very, very important point I have to stress is do not edit while you write. You may be making mistake or you may not be getting the perfect sentence, but just write first. Just write it down, and then when you have something on the paper, you can go back and edit. But if you start editing while you are writing, it is going to slow you down big time, and you will not be able to write even a single paragraph. So don't think about whatever mistake, grammatical errors you're making. Just put down the content that you want to include in that section while you're writing the section. You can definitely ask for help, ask for a second pair of eyes, your friend, your colleague, to review your draft towards the final draft stage. It's very helpful. But word of caution is when you have your draft under review, do not edit it. It does not reflect good. If your friend spends 2 hours editing your draft, and the next day you tell him, oh, yesterday night I edited the draft a bit. That the efforts of your friends are wasted. So don't do that to your friend. All right, so you have a final draft in your hand and you're ready to publish or submit it to the journal. So submitting your manuscript is also a few steps. So I would request you to put comment. Also, what you can do is you can do a mock submission to just know what all documents are required for submission, how your paper should be divided. Is there any format, line numbering, spacing between the lines, etc. So that's a good idea. Once you receive the peer reviewer comments for revision, you need to respond to those peer reviewer comments and make any changes that they have suggested in the manuscript. Also, the next stage is checking the galley proofs. So the journal will usually send the galley proofs to you for a final check. Make sure, check all the figures for any data error, figures, tables, text, and any grammatical error. And once you have approved the galley proof, then it's in the journal's hand to publish it. And yeah, it's a very happy feeling to be a published author. So I hope all of you have that opportunity very, very soon in your career. So moving on, I'll spend a little bit time talking about English language and sound. So most of us are, I believe, are non-native English speakers. English is not our mother tongue, and the scientific communication that we are talking is done. And for any language, grammar is an important component of uh, English language as well. And so, whenever you are writing something or orally presenting something in English, it should be grammatically correct. And not all of us will be as fluent speakers or writers in English. And I have to tell you this, that scientific communication is not same as native English speaking. So even the native speakers of the language have to try and acquire the skill of scientific communication. So don't be afraid of writing in English, or if you think your grammar is weak. Because I have seen even the American students have the same struggles of writing a good paper as a non-native English speaker. And there are ways to improve. Since it's an acquired skill, you can improve your skill. And the first thing you should do is analyze your strengths and weaknesses. So, what is it that you are weak at? So it's not enough to say my grammar is weak. So what exactly? So is it the subject verb agreement? Is it the tenses? Is it the active passive voice? Is it the use of prepositions? I don't know where to use from, since, when, or the use of articles. I think Indians are inherently poor at using articles, and we don't know when to put we overuse the sometimes, and they, so these are all nitty gritties of grammar, and you should analyze yourself. Say, write a paragraph and try to look for your own mistakes where you are going wrong, and then try to improve those specific grammar, whatever the skills, right? That way you will get better quicker at writing. And when you are writing, there are two friends that you should regularly consult: the dictionaries and the thesaurus. The dictionaries will tell you the spellings, whether it's the UK English, US English, and the distinction between the two. And thesauruses come very handy when you are writing a paper, because it will offer you 10 different words of similar meaning for one word that you put in. Like if you are saying the results demonstrated, then it's going to give you 10 different words for demonstrate that you could use instead of using the word demonstrate all throughout your paper, which may sound boring after 3 seconds. Then there are style guides. For example, AMA, American Medical Association, has a style guide that's followed. There's APA, and these are available online. These resources you can check out and language and grammar. Uh, there are various apps. You can basically pick up any basic English language grammar book like Ren and Martin and start reading it. It's going to make you more confident as you go along and practice those rules, in your everyday life. And coming to the end of this presentation, so this is the last slide, and I would say that writing better is a work in progress. You are never, you can always be better from what you were yesterday and today. So it's a continuous process. And for scientific written communication, the best reading size would be reading papers from reputed journals. NEJM, JAMA, Cell, Science. Some of like these are all subscription-based journals, but some of the articles are open access, and you should definitely check out the articles in your field from these journals or any journal that's reputed in your field. And while you're reading that paper, note the style, how they have formatted the introduction, how where do they put paragraphs, how they write the method. Can you see the basic rules of English grammar, where they're using commas, semicolons, etc. So reading consciously these articles that are published in the reputed journals is going to improve your knowledge and vocabulary of English or scientific communication skills. And it does happen that, especially when you want to write your thesis, it's a lot of work that you have done. And when you sit down to write, nothing comes out. That's a writer's block. Now you can't think of anything. And the solution is to write more. But I will tell you what my professor in the university taught me. He gave me a very simple writing exercise, which is random writing. So you write, you take a pen and paper and put the timer 10 minutes, and don't take the pen away from the paper for next 10 minutes. Whatever comes to your mind during those 10 minutes onto that paper. What that does is that takes out the block that's in your mind for writing, and then you can go on to write what you really want to write. As a exercise, you can also practice writing about your research. There will be multiple occasions when you have to talk, like give a summary of your research or submit something that talks about your research. So you can start practicing that document, writing about your research into 500 words or 300 words. Other way is to summarize an article. Don't look at the abstract, read the paper and try to write the abstract on it. So all these exercises will improve your writing skills. There are also, of course, online courses available on Coursera or edX, and you can check those out. And the last important point is help each other. Helping a friend to review his article is going to improve your skills of language as well. So it's a two-way street, and the more you help, the more better you will get at writing yourself. So I will stop here. Manasi, you want to continue right from here, or do we want to take a break? Vivek sir?
1 second. Yeah, it's if you would like to take the questions, there are already the questions are available.
Take the questions after Manasi.
You prefer that? Not an issue. Not an issue.
So, Manasi, you want to go ahead? I'll stop sharing this.
Sure. So how about we all take maybe 30 seconds break, stretch, have a drink of water, and come back?
True.
Because we just heard a lot of information, and I don't want you guys to get overwhelmed with more information from my side.
Manasi, your video is muted.
Yes, I know that. Yeah, I will
your
open it.
presentation. By the time I'll have few, maybe kind of a chat with the audience.
Sure.
Yeah. So.
Okay, let me share my screen in the meantime.
Yes, sure. So,
And
dear audience, I have something very interesting which my dad has told long back. For example, why are we here? Why are we sitting here? Why are we watching this? The main reason must be to learn, right? So, what are the pillars for learning something? So, it's a four pillar. It is the article is available on UNESCO. If you search for four pillars of education, it starts with learn to learn, the first one, and the next one is learn to do, and the third one is learn to be, and the fourth one is learn to live together. So the first one is learn to learn. That Jidnyasa has shared a lot of information how to learn, for example. Or if you look at some article, or if you look at newspaper, if you look at movies, there you learn, right? So you get information through that. And the second one is learn to be, where how you have to be. If you have a lot of knowledge, how you should be. So in when I was very young, so this is one of the chanting which I heard, or which is taught to me by my teacher. Is it audible? Is it a lot of echo? I'm not sure.
No, you're perfect.
It's audible? Okay. So, Anurag, on the live, how is it? Sorry if...
Jidnyasa, it makes the sound quality better if rest of the speakers switch off the video when somebody's sharing the screen.
Okay.
So that happened when I switched off my video.
Great.
When Jidnyasa was talking before.
Okay. I will also switch off accordingly. So I'll continue from there, where we are at learn to be. So how to be? So if you learn to learn means how to learn, okay? And learn to be is how to be. That is, I was talking about my teacher, Sanskrit teacher, who taught me when I was very young. Vidya dadadi vinayam, vinayadyadi patradam, patratva dhanam apnoti, dhanat dharmam tata sukham. So Vidya gives us vinayam. If Vidya didn't give vinayam, then we are not doing it properly. Vidya dadadi vinayam, vinayadyadi patradam. That vinayam will give a character to us. And patratva dhanam apnoti. In that character, dhanam is not just the money, it is also suhur dhanam, or you can vidya dhanam itself. So dhanam doesn't mean just money, okay? Dhanat dharmam tada sukham. If you have it, you have to share it, like what Manasi and Jidnyasa is doing. They are sharing their experience, their learning to others. That's how we get anandam out of it. So tata sukham, we get happiness out of it. I'm sure they both are enjoying it, doing so. And from there, learn to do. If you learn something, you should do and practice that. So only then it'll be perfect. If you just learn a lot of theory, unless you go to the lab and do an experiment and find out by yourself, do it yourself, it will not be enough. You just learning is not enough. You have to do it as well. So that is something very important. From there, it goes to learn to live together. That's where we are all in. We are all together now. We are watching. More than hundreds of people are watching, and we can learn together. That is called live together. Which is yeah, that's what I want to share. 4 pillars. Can anyone type this into the chat if you are listening to it? Maybe I can also be happy that you have got this properly. Okay, by the time Manasi is ready, I think.
Yeah, can you guys see my screen?
I'll just add it. Give me a second. I have to. So Manasi's presentation is there. So you can see Manasi also. I'll just hope this is visible for all.
Okay.
I have to adjust this.
Sure.
Sorry, there is some issues in between. The auto text which is coming, which is for your help, but sometimes it creates a lot of unwanted things coming in. Sorry, it is because maybe Google is not taking it up properly. So I mean, the way I talk or the way I pronounce will be different from how in another country, because it's a machine learning. So there may be mistakes. I'm really sorry for it. We will take all the questions together as Jidnyasa has suggested. So I am handing over this to Manasi. All the best, Manasi.
All right. Thank you, Vivek sir. So let's dive into second part of our webinar today, and I'm going to give you some guidelines and some tips and tricks about how to be a better presenter, how to give a good scientific talk. And it might be just a visual talk, just a poster presentation, or it might be a thesis presentation where you have to talk to support the slides that you're presenting. And I believe that no research is finished until it's shared with others. But unfortunately, in our training as a scientist or as a researcher, we don't really get formal training how to present your data, especially in a visual format or especially using your voice. You never get a training of how to really give a seminar properly. You get a training maybe how to write a grant, how to write a review, how to write paper. Maybe some senior student from your department helps you to train you to make better posters, right? But I'm here to tell you a little bit more into details of how things are done and how you can be effective as a scientist, as a researcher, when you communicate using oral and visual format. One of the things that we shy away as scientists is sharing our data before it's publication ready. And I think it's a big mistake that as a scientist or scientific community we do. We actually should encourage sharing our data much before our story is complete and ready to be published in journal as a paper. Because what scientific conversations do is they allow you to actually explain your own story, own scientific talk to many people, and during that conversation you yourself learn the same experiments again and again. You yourself think about your data again and again, and maybe you think about what all could go wrong if I start to write this story, what other control experiments I should do before I put that in my paper. It also can lead to many collaborations. If you talk about your poster, if you talk about your continuing work in conferences, may not be a complete story. You might be just a first year PhD student, you don't have much data, but what all you have in the poster might start the conversation with an established professor in your field about how they can collaborate with your lab, how they can provide you with different techniques that are already developed in that lab. So it matters a lot to communicate your science, and it matters that how you convey the message is important. Talking science is never a bad idea. The trick is how you do it. If you do it properly, it conveys scientific message very, very efficiently, and that relates to the research community being respected, being given that credible respect. We are considered experts in our field, right? But the expert title only comes if you can tell other people what you do properly. Otherwise, there are going to be miscommunications, misunderstandings, and misconceptions about how the research is done. And it's very evident in this pandemic situation today. There are lots of studies floating around online about how vaccine is developed, how it's faster, it can be done in 3 months, why is it taking 3 years otherwise? And people really don't understand the research process behind any scientific process. They don't really understand how long things take to actually give you real result, how long it takes to really publish your data in a scientific journal when you're doing PhD, right? So if you communicate with your peers, with your colleagues, with your friends, with your professors, with your community, it not only helps the community, but it also boosts your own self-confidence. You tend to talk better if you practice talking to others, right? And picture is worth 1,000 words, and it's really, really true. You're looking at a science magazine cover from about a decade ago when the data science field was just up and coming, and they decided to do an entire science magazine issue focused on data science. Now, they could have designed their cover page in a very boring manner. They could have used different networks and algorithm names and all those things, but that might not have been attractive. But right now, what you're looking at is one of the highly, highly cited cover stories from Science magazine. And that is because they have used very popular image form called word cloud to basically demonstrate the complexity of data science. There are thousands of words in this data cloud, but only things that show up on your screen are these big words called data, research, information, analysis, visualization, and many others. So just by putting focus on these important points in this word cloud format on a dark background, they have made it attractive for the readers to actually flip the pages of this issue and understand more about data science. So this is the importance of communicating science in a visual format properly. So any good seminar that you can remember potentially has multiple reasons for you to remember it as good. Maybe because it was presented to you in a very, very clear format. The speaker was very good in talking. They made eye contact with you. They were telling you a story. They were taking you on a journey. There was a flow, and you could actually understand one after the other what they were telling. There was a logical flow to their experiment, right? All these sound familiar as a scientist. Well, that means you already know what it takes to communicate science properly. Any good presentation always tells a story. So every good presenter or every good scientific presenter should always tell a good scientific story. And think about a movie story for that matter. You like a movie because it has a great storyline. It starts with a good background, then it has a strong middle where things happen and you are stuck to your chair finding out what happens at the end or the climax of the movie, right? So how about we use the same analogy of framing the story to your scientific talk? Your scientific talk or research talks or any presentations for that matter should have 3 parts or should have 3-part structure. It should start with introduction. It should have data in the middle as a star of your talk, because science is the star of your research talk, and it should always be like that. And you should end your story with a climactic conclusion or a strong take-home message. So always start by structuring your research talk into these 3 parts. And for structuring your talk, you also need to know the concept of mapping your story. What I mean by map here is you need to know what the message you are trying to convey to the audience. So that also means you need to know who your audience is. Who are you giving this talk to? Is it a lab meeting where you're presenting to your lab mates? Is it a thesis defense where you're possibly presenting to the entire department and not everybody knows details of your project? Is it a conference presentation where people from across the community are listening to your poster presentations? And what is the purpose of your talk? Are you updating your lab mates on the weekly progress that you've made in your project? Versus are you giving them the overview of entire 5 years worth of PhD work in your thesis defense? In one format, you're informing them. The other format, you want to inform, engage, and convince them to give you a degree, right? So the purpose might be different and you have to tailor your story accordingly. And both knowing who your audience is and what your purpose is going to drive what your message is. Message means your take home message, the summary, the strong point of your talk. You need to know what to highlight from your entire talk. And all this mapping revolves around how much time do you have. If you have 10 minutes talk versus you have 60-minute talk, your messaging changes, your purpose changes, the audience reception changes. So you always have to frame your story by knowing your map. So remember this short form: message, audience, and purpose. All right. So in today's talk, we are going to talk briefly about the research talks or research presentations. So I have alluded to different examples of them, but just to reiterate or repeat, that might be lab meeting, journal club, conference presentation, poster presentation, thesis viva defense, right? Okay. So I have divided my talk into roughly two parts. The first part is actually developing an effective presentation. And in the second part, I'm going to tell you how to deliver a great presentation. So let's start with developing an effective presentation. And when I'm talking about presentations, I'm basically talking about developing PowerPoint presentations or slides or posters or a new concept that's emerging in the field called graphical abstracts. So the main key idea about communicating with any audience, any research or non-research audience, is to connect with the audience. You need to engage them with what you're talking. And this comes a lot with your efforts into making that presentation and delivering that presentation. That also means you cannot make the presentation at the last moment and expect it to be great, right? And if you know how to do that, it's a magic trick. And please share it in the YouTube comment section. What is the magic trick you use? And I will be happy to share it with the rest of the world. But I'm going to bet on it that that's not a magic trick that works for everybody. Everybody who gives a good presentation needs to plan it, needs to prepare it, and needs to practice for it. We all have idea about how the research talks go, right? We already always give this ABDC frame, and that's sort of similar to the IMRAD approach that Jidnyasa mentioned in the scientific writing part. So you always start with the outline or agenda, that's the A, background or introduction, that's the B, and data or the middle crux or meat of your presentation, that's D, and then finally the take-home message or conclusion, that's the C, right? So we already know how to structure our talk that way. We can take our paper, take out our figures from the paper, or take out our, old slides, or maybe just, do the presentation at the 11th hour by putting together just a couple of slides and just reciting the same slide text as is. But is it going to serve the purpose then? I can already see the data on the slide. Why are you reading me the same slide again, right? The audience is expecting the interaction. Audience is expecting conversation with them. So scientific talks always need to establish that connection. I need to know more than A, B, D, C frame of the talk. I need to know these details. I need to know the discussion. I need to know your thinking about what you think about this data, what you think about this Western blot. Why do you think this is telling you the result that is not expected, right? You also need to think about other things before and during presentations. Just simple things like how much time do you have to actually prepare the presentation? How much time do you have to actually give the presentation? How big is a room? How big is the audience? Are you going to use microphone? If you're going to use microphone, are you comfortable with it? Have you tested your voice for it? Are your slides properly getting projected on the screen? All these are technical details, and scientists tend to think they are trivial. But if you want to communicate your message properly with the audience, you always have to think about all these trivial details because they make up a whole lot of sense in a bigger picture. During the presentation, of course, you need to focus on what you're talking about. You also need to think about what audience is experiencing. You have to ask yourself, are they following? And it's very evident if you actually look at the audience and see if they're following your presentation. If they have questions, their body language changes. If they agree with something that you have said, most of the times they nod or their body language is more positive, right? They become relaxed. If they have question, they might ask you a question in the middle of the session, and that might break the flow of your talk, but that's fine because that also means they are attentive towards what you're talking. So these are the considerations I want you to think about when you actually prepare, plan, and practice your talk. So let's get into the cycle of this prepare, plan, and practice. And it's a cycle. It's not a one-time process. That means you cannot just work on one presentation and become the greatest presenter of all times. For every presentation, the process repeats. And just like research, you always reinvent the same things over and over again by doing different experiments, doing different tricks, use different styles, see what helps you becoming a better presenter. All these things that I'm telling you today are just the guidelines and suggestions and tips and tricks that have worked for a bunch of us that I know in the field. That may not be your style and by no means should be your style. Every presentation should have its own style. But the only idea behind effective communication is that it should follow certain ground rules. So planning and preparation starts with you thinking about your presentation. How long is your talk? Who's your audience? What is your purpose and what is your message? Mapping your story comes at the idea stage. That's right at the top of your screen now. You also need to know how you want to structure your talk. Is it a 10-minute talk, 60-minute talk? And you need to divide your talk accordingly, right? So keep in mind, depending on how long your talk is, you pick and choose key pieces of data to project on your presentations, right? You don't want to show 20 slides for 10-minute talk and then overwhelm the audience, because then you're going to lose the audience. They are not going to be interested because they just think, oh my goodness, this person is trying to just impress me by saying, oh, I could do this much work in this much time. But there is literally no discussion about why you did this work or what that result mean in the whole story. So think judiciously, plan properly, think about how many slides you can put. Genuinely think about how much time you have to prepare those slides. And preparation comes as a second step. Start drafting your presentation. For me, drafting stage comes with opening up a PowerPoint presentation, a blank presentation, and just starting to put titles on blank slides. It might not be your style. Some people actually take pen and paper and jot down bullet points. For me, when I'm designing poster, the first part is actually I take a paper and draw a rough layout of what I want to go where on the poster. So find what suits you, but I want you to make an effort to actually come up with a rough diagram or rough layout of your presentation. What that does is it focuses you onto that task of making the presentation and gets you in that zone of now I have to make the presentation. Now this time is devoted for making that slide properly and then maybe working on it as you go along in your preparation phase. You also want to think about how much data, where does it go? You can, build your slide decks properly. You can think about how many slides you want to show and what is the flow of your talk. You can also start thinking about what text follows which slide. What are the transitions between different slides? If you are showing 3 pieces of data, maybe you need a question going from one slide section to other slide section. Data A resulted in this finding that opened up this question, so I addressed it by using XYZ technique, right? So what was that question that linked data A to data B? That question becomes your transition. And think about the transition slides very, very carefully, because they are going to set the tone for your presentation. At this time, you can also start practicing your presentation with colleagues or lab mates or family friends, or maybe with yourself. If you're a shy person, if you're an introvert person, you are nervous about public speaking, one pro tip that I can give you at this point, try and practice your presentations in front of the mirror. People tend to get nervous when they see themselves in the mirror or on the screen. But then if you can overcome that nervousness, then you become more confident in giving the presentation. If you are talking to people and practicing with peers, ask them for feedback. Ask them, can they follow you when you talk? Are you pronouncing things correctly? Are you going slowly enough that they can follow the logical background behind why you are putting that data in that order? Does it make sense? That's the question you should ask to your friends. And if it doesn't, don't take it personally. It's for your betterment that you're getting this feedback. Go back to your slide, rework those slides, change them so that they are more clear and your message is effectively communicated. And after iterations of that, just like how you have drafts of your papers, you can have drafts of your presentations. And over time, it will become better and better and better. And that's when you can start to give effective presentation. And this cycle repeats, as I said, the next talk comes. Of course, you can recycle some of the slides. You can reuse some of the slides. But then the story changes because the talk is different. So the map of the talk is different. All right. Main idea behind any research talk is that science is a star of your talk and data that supports that science has to be accurate. There is absolutely no way about it. Visual presentations and oral presentations help you narrate the story, but they need sound, solid, reproducible data to back that story. And that also means when you're depicting things, you have to be always vigilant about how you put together figures, how you're representing data, how you're labeling your graphs, how you're putting the nomenclature for, let's say, microbiological species or gene names, or the scales that you use for microscopy images. All these tiny things are considered to be accurate measurements of how the scientific talk is perceived. So you have to be accurate. Your data cannot be one-time fluke data. If you haven't done the same experiment couple of times and if you are not confident about the data, don't be in the hurry to show that on your poster slide. People don't like it when the scientists come to the conference and say, I just got this slide from my postdoc. He's been working really hard all this while I'm here in the conference, and he just sent me this data from the experiment he finished last night. And although this is preliminary and we really don't understand the whole story behind it, I would like to share it with the rest of the conference community. In my mind, I'm thinking, why should I think about this data right now? If you are not confident about the whole story, you yourself said that it is a preliminary, so-called, just out of the oven data, then maybe don't show it to me. This is not a competition of who gets there first. This is a field where reproducibility matters. Science relies on reproducible data. Of course, you need to show novel things, but don't do that just for the sake of it. Attention to detail also matters. What I mean by that is you absolutely don't have to have any typos on your slide. No grammatical mistakes on your slides or presentations. No formatting errors on your presentations. If one section is with a box, make sure that you format all your sections with a box around it. Unless you want to make a point using that boxed feature as your focus point. People don't like to see unrequired texts or images on the slide. If you're not going to talk about that, I don't want to see it on your slide. If you're not going to show me 3 different bar graphs of controls, then don't show me that, okay? Only include things that you have time to explain. And if you practice your talks well in advance, you already know how much time you are going to spend on each graph explaining that. And then you can take out the unwanted, unrequired supporting data. Keep key pieces of data and then explain it better rather than showing 20 supplementary data figures. And last but not the least, no last minute changes. Because it's possible that those last minute changes might not work in your favor. You might add a microscopy image thinking that it supports your data and it actually is like a big piece of data, but it might not show up on your presentation because you didn't save it properly or it didn't get exported properly from the microscope itself. So don't make any last minute changes. Stick to the version that you are comfortable with, what you have practiced. And just as a thumb rule, again, a professional tip, just because you can doesn't mean you should. What does that mean? Just because you can work all the fancy features of PowerPoint presentations or Adobe Acrobat Suite or any other Google search engine, that doesn't mean I need to see that in one presentation. I don't want to see multiple slide backgrounds, multiple animation effects, multiple types of graphs just because you can, right? So keep it minimal. Data should be the center star of your talk. Generally speaking, in the scientific talk, less is more. So if you have less content per slide, you get more time to explain that content. If you have less clutter on your slide, the slide becomes more clean and you get clarity from the audience perspective. You can explain it better. So less is more. All right. One of the most important things that you can think about to make your data appealing and attractive is introducing visual hierarchy. It's a graphic design principle, but in a simple term, what that means is you tell your eyes where to look first and second and third on the slide. So this central box is exactly doing that. Right after I put on this slide, your eyes got drawn to the text, your eyes here. And then you probably read introduce visual hierarchy, but if that wouldn't have been there, then you would have read then here and then. Isn't that fascinating, right? So it is a way our brain catches the information on the screen when it's displayed. It generally gets drawn to the biggest, boldest, visually contrasting things first. So you want to set up your presentations in that way. You can do that by using or playing with different color fonts, different size fonts, different styles of fonts, spacing between things, and of course, open space. So if you have noticed, both me and Jidnyasa, we have used dark background and contrasting colors for our text, but we also have lots of open space around our slides. So our slides are not cluttered. And that helps us to focus on the main central idea of your presentation. And that sort of makes it clear and less confusing for the brain to absorb. Let's think about the text. And I know this is a wordy slide, but it is a text slide. So I hope you get a pun in that. So text of the slide, keep in mind that it's a guide to your talk. So please do not read out your slides. The slides are supposed to help you tell the story. Slides are not there as themselves, as a self-explanatory talk. All the slides with texts should have short informative titles. So please don't use result 1, conclusion 3, control experiment 2 as your titles. The title should have some meaning to it. So it might be a question that you're addressing. And if you're putting out the question as a title, end it with a question mark. It might be a conclusion. And in that case, it will be a simple statement, but don't put period or full stop at the end of it as a stylistic measure. You have to use clear, visible, and legible text. So that means you have to be very, very careful about balancing the font sizes. You have to be very careful about what keywords you're going to use to tell me about things on that slide. So it can be in the bullet forms, it can be in different slide layouts, but make sure that it's not wordy slide. It should be clutter-free, it should look presentable and appealing. Always use fonts which are easy to read and clear. That means serif and sans serif family fonts, and colors which are web safe. In today's world where most of the data that we are looking at is shared digitally, you have to think about which colors act properly or get projected properly on the big screens. And think about those colors and use those colors. Do not use Comic Sans as a font in your scientific talks or presentations. As the name suggests, It's developed for comic or cartoon strips or children's books and not research docs. So let's not use it. Okay. Serif and sans serif fonts. What are some examples of those? Arial, Helvetica, Times New Roman, Avenir, Tahoma, Georgia, Garamond. All these are types of serif, sans serif fonts. Don't worry about remembering these names. We will be sending out resource links where I will put out list of serif and sans serif fonts for your references. And of course, you can Google them. The most important part of text slide is if it has to be wordy, I want it to be appearing in the order that you're going to explain. So let's say there are 4 points on your text slide. Then you should be talking about point 1 first, and then go to point 2, and then go to point 3, and then go to point 4. So order of the text should match the order of explanation. All right, let's go to the visuals. What do I mean by visuals? They might be graphs, they might be actual presentations, they might be some artwork. It might be suitable, that might be suitable to your story. It might be a bioinformatic analysis that you have put in different formats. It might be images from your microscopy or real-time videos, whatever may be the visual that are helping your storytelling in these presentations. Think about a layout rule called CRAP. Okay, CRAP stands for contrast, repetition, alignment, and proximity. So always think about high contrast when you're designing your visuals or presentations. So that can mean light background, dark text, or dark background, light text. But be careful about what colors you choose, right? Repetition. So if you're thinking about using one style in one presentation, keep repeating the same slide so that it's continuous, it's consistent for the people to understand. So let's say all my headings are in yellow and all my subtext is in white throughout this presentation. So that's my repeating motif, or that's my repeating style for this presentation. You can change the color schemes for the next presentation. You can play around with that. You can also play around with the same color but different type or spacing. And that also repeats this. It's same principle of repeating. Alignment. Especially when you're considering poster, alignment becomes very important. If you are showing 3 pieces of bar graphs, make sure that they all are of the same size. Make sure that all their legends are in the same fonts, same font size. Make sure if your wild type bars are represented in black color, then use black color for all the wild type experimental graphs that you use throughout the presentation. So that once the audience knows that, okay, I associate black color here with a wild type and a red color with a mutant, then the same color scheme follows through the presentation. So it's easier for them to understand and assimilate the data. And remember that research talks can be very, very data intensive. So you want to make sure that you want the audience to take as many data points away from it as possible. But generally speaking, people tend to only remember 3 major points from your talk. So think about what those 3 major points should be and make sure that you are consistent in convincing them using this CRAP rule. The last part of CRAP rule is proximity. If you're designing posters, that means that things that are related to each other are spaced closer to each other. They are proximal to each other. So the title is a completely different part than acknowledgement. So they should be completely separate in different sections. So thinking about all these layout patterns and designs and styles will allow you to make more effective presentations. Again, do not overwhelm your audience with data. 1 or maximum 2 related contents per slide. If you want to show 15 graphs, go ahead, but make maybe 15 different slides so that people are not confused. No unnecessary animations. Remember what I said, just because you can doesn't mean you should, right? And center spacing. Sometimes people overlook this point, but I think it's very important from the point of view of visibility. Generally, all the rooms where we present are just flat, plain surfaces. They are not designed as a theater. right? So the chairs are all on the same level. What that means is if your important data shows up at the bottom corner of your slide, there is a possibility that people in the back row are not going to see it. And they're going to lose out on a very important piece of your story. So you want to avoid that and make sure that most of your text or most of your data is in the middle portion of your slide and leaving the borders of at least 1 inch from all the sides of your story. It also allows you to be flexible because some projectors like to change the dimensions of your screen. So things might get stretched and you might lose out on your data or your text if it goes out of the window. So keep it center spaced. And as Jidnyasa also mentioned, always refer and cite your resources if you are using open source images from Google or any other source. And only use permitted images if you're downloading it from the web. Do not use copyrighted material. It's called art plagiarism and you don't want to do that. So let's look at some quick examples of effective posters. I've given you all these guidelines to make posters properly and effectively. I know you can always make good posters, but the idea is to give you tips and tricks to make every poster, every presentation a great one. And I think these two posters do a job very nicely because of their color scheme. We talked about crap rule. It's been used very effectively. Things have been placed in such a way that related things are in one section. The visual hierarchy is set up. So in the purple poster, the visual hierarchy is set up by using this big block of purple right at the top. So people tend to read the title there first. The other second part that you're going to get attracted to is a second rectangle in the middle portion of that purple poster. And I'm going to tell you in a minute what you can do with that second focal point. But look how they have represented the data in poster here. They have used different formats of presenting data. So people get really bored with the posters or presentations if only one type of method is used to generate data. So I always tell people that mix and match things, mix and match techniques, mix and match way of projecting your results in different ways. So on one slide, maybe you can demonstrate your results by a pie chart. On the other slide, you can use microscopy images. On the third slide, maybe use bioinformatic analysis. On the fourth slide, you can use bar graphs. You can use the horizontal bar graphs or vertical bar graphs, again, using the same color scheme, consistent layouts, but just try and play around with different ways you can project your data. And that makes it more interesting than me looking at just 20 Western blots or 20 gel pictures in the same presentation, right? People also tend to think of you as a better scientist because if you are using different techniques, that means you can do those many techniques. So you are skilled at those many techniques, right? So you become more hireable candidate, more important when it comes to hiring you as a postdoctoral candidate or even in the job market, right? So use your presentations and posters as an opportunity to showcase how many things you can do, not just with your data, but just visualizing the data, projecting the data, presenting the data. All right. I told you that I'm going to focus and come back on this purple box that's in the middle portion of the poster, right? And what I mean by that is generally that is used to give you the takeaway message or main key findings of the poster, right? Because right after the project title on that purple poster, your eye grabs the attention of this purple box. So how can you use it effectively? Well, you can put your take-home message right there. You can give overview of your poster right there. Another way of effectively giving overview of your poster or your work is this new concept called graphical abstract. So what is graphical abstract? For those of you who don't know, many more scientific journals are nowadays asking this in addition to the text abstract that we submit to the journal. And it's essentially a single figure research summary, and it's sort of a promo or a trailer to the actual movie or actual research article. if you can attract the reader, and if the reader understands what's the meat of your paper, what's the key data of your figure, just looking at that figure or a graphical abstract, they are more likely to then click on the full text of that article and more likely to then read the actual article. So it's serving multiple purposes. It's serving the publicity and visibility purpose, because nowadays everything gets shared on your Facebook, Twitter, LinkedIn, Instagram handles, right? So it's a figure, it's an easy format to upload it on your social media, it's easy format to publicize your science in today's age. But it's more important for me to use this graphical abstract in more than one way. Think about it as a take-home message or a visual hierarchy tool to use in your poster. So this, especially the example that I'm showing you, you can envision this graphical abstract in the space of this purple box. And that means right after I read the title of the poster, I'm going to look at this graphical abstract. I'm going to get the key point away. And that means I will be more interested in reading the rest of the details of this poster. It's also a great way to recycle and reuse your slides, which are made really well, because then you can take elements of those slides and put together a neat graphical abstract. The other professional tip I'm going to give you is use graphical abstracts as your elevator pitches. Sometimes very busy scientists come to your posters and they only have few minutes to listen to you. So what they do is they say, okay, just tell me the main important key point out of your poster. I don't need details, I don't need background. And then we fumble as to how to frame our 10-minute poster discussion into this 1-minute talk. That's where graphical abstract comes in handy, because you already have all the key information on that graphical abstract. So you can then explain them, what's your take-home message, what's the key data. So in this particular Zigir graphical abstract example that I have, the take-home message is, okay, there is something called Zigir. What does it stand for? Zinc granule indicator. Great, right? Few keywords, what they have used here. Zigir is a surrogate marker of insulin granules. It's very simple sentence, few keywords. It's enough to tell me about their key piece of data, that it's some sort of a synthetic substance that can act as a marker for insulin granules inside the body. And they have shown that with a great piece of microscopy where they've labeled Zigir again throughout the abstract with red. Insulin comes with a green. The microscopy image shows it with green. So they have made that consistency rule applied here again, right? It's self-explanatory to the point. So just looking at it, even if I don't have a text abstract to read next to it, I can sort of get the message. If there is a text abstract next to it, great, because posters always have the abstract factor most of the time. So it sort of is mirroring to what the journals are doing, right? So use graphical abstracts very, very carefully. But if you can make really good graphical abstracts, go for it. Use it to your advantage. Your style of making graphical abstract changes. It depends on the journal you're submitting. So you have to read the guidelines provided by the journals. Use earlier examples as your starting points. So let's say you are discovering a novel pathway, then maybe use flowchart kind of a method or a workflow kind of a method. If you're developing a new technique, then your graphical abstract should have key details of how that technique is performed without giving away much details, because that's the whole idea of reading the whole paper. You don't want to give away the whole thing. It's just like a good promo of a movie. If you give away everything that happens in the movie, nobody's going to come to the theaters to watch the actual movie. So just think about graphical abstract as the movie promo or trailer. Okay, we are coming at the end of the webinar, but I want to spend some time on the second part of today's talk, which is delivering the actual effective presentation. And people don't think about that as an important part because they think science should talk by itself. Science is a star, so if I show promising data, if I show solid data, that should be enough. But science doesn't get perceived properly, doesn't get communicated properly unless and until you narrate the story properly. If you're just standing there and let the data talk, That's not going to help the audience because the data is not completely self-explanatory. Audience needs you to elaborate on it. And what I'm showing you here are 5 pillars of giving exemplary talk, 5 pillars of connecting with your audience, engaging them, making sure they understand your talk. And it starts with your body posture and body language. People tend to lean on the podiums when they are talking from the podium or stages. People tend to fidget a lot. They have tendency to move their legs, pace across the stage, even so that when they understand they are obstructing the view if you're walking across the screen. So please do not do that. Try to limit pacing to maybe a couple of steps. If you get nervous, that pacing speed changes, and that's very evident. So you don't want to show your nervousness. Getting nervous is natural, but you have to work around it so that you become more confident. You becoming interesting and interactive during the talk is going to make audience more interested in listening. And that's the whole idea, right? So you have to look confident. You have to be the sole expert in that room. You should think about yourself as the person who knows the most about that story in that point. And then because you are in that position, that's why you're giving that talk. You don't fidget, don't play with the laser pointers, especially if you are a nervous type. If you get nervous while you talk, then the laser pointers that you're going to use are going to shake. Okay, professional tip number 1. If you don't want to give away that you're nervous, try to hold your laser pointer with a second hand, and that stabilizes the laser pointer. Also, don't put the laser pointer towards the screen and move it in the circular manner. Just point it towards what you want to explain at that point, and then just leave it away. Okay, so it's a momentary flash of laser. Make sure that your pointer is working. Make sure that you get there on time. All these things come with practice, but you want to put that practice in the actual presentation manner. The third important point is eye contact. You are talking to people. You're talking to either a group of people or just one person if you are giving a poster presentation sometimes. And making eye contact is hard. It's nervous. Sometimes it's intimidating. I completely agree. But there is no way that 2 people can converse if one person is just looking at the floor or just looking in the sky, right? So you have to make eye contact. And there are tricks again that you can use. If you have many people across the room, one trick that you can use is you scan through the room. So you do not make eye contact just with one person in one corner and then one person with the other corner. You actually scan the entire room. What it does is not only it gives you breather and makes you more calm because there is no pressure of you making direct eye contact with one person, but even the audience feels the pressure to be engaged because now they know that you are looking at each one of them at one point or the other, right? So it's a trick to keep them involved and engaged. Other thing, if you have anxiety issues, if you don't really like to talk to people by looking directly into their eyes, try to look at their eye level, but between 2 people. That creates an illusion of you looking directly at them, but really you're not. So that calms you down. But you absolutely have to talk looking at the people. Do not show your back to the audience. If you're doing poster presentation, go back and forth between pointing the data on the poster and then looking at the audience. That gives, again, the sort of continuation pattern to your talk. Again, voice, volume is very important, right? If I give this talk in a one monotonous voice at this one pace, it will be much, much, much boring, and I'm sure you will stop watching within a minute. So volume, how you change your volume, how you change the way you speak, how you ask the question should be different than how you state the conclusions. And it should change automatically. You can use some gestures. Like I like to use my hands a lot. Sometimes people don't use that. Sometimes people are very introvert and they like to fold their hands. It's okay, whatever works for you. But make sure that you implement all these strategies to a certain extent at least, so that you are more conversational and then the information that you are giving the audience is actually reaching the audience. And the last but not the least, it's very important for scientists to dress presentable. Please do not think that science is this field of geeky, nerdy people who don't care about their looks and presentations. And presentations are people who are in the movie business. No. We are in the world where presentation matters. Would you take a doctor who is dressing shabbily very seriously if it treats you? No. Right? So if you expect the doctor to be a certain way, why not you as PhD students or who are becoming doctors by themselves? You are experts in that field. You are respected in that field for your knowledge, but you are also respected on the basis of how you present yourself. So always be presentable and professional. Any scientific talk that you give is not an elocution competition. It's not an art competition. It's a research talk. So star of the talk should be science, but you are the narrator of that science story. So you have to be professional and presentable. And just like Sheldon Cooper, who is a nerdy, geeky character and who doesn't care about the world or the perception of himself through the world, even he dresses up when he wins the Nobel Prize. He looks very professional, right? So if the TV characters can change their persona, the real people like us doing the work and real researchers like us should make an effort to look presentable. And it's not only giving you credibility and respect that you deserve, it's going to change the perception of the people that looking at you. In turn, it's going to increase the confidence on you and in you. So you will become more confident about how you talk, how you give the presentation, and that's going to result in how you engage with people, how you communicate with people. And that's the whole idea of scientific communication. One more example to drive the point home. Sir Stephen Hawking, one of the most brilliant minds of our generation, right? He doesn't need to impress anybody. He doesn't need to convince me that he's a genius or expert in any field that he thinks of. But even he, at his stature, makes it a point to impeccably dress well in professional way, right? For any public appearance that he went for throughout his life, he was always very professionally dressed. So if a brilliant mind on this earth takes time to dress properly for all the public talks and research talks and scientific talks and public meetings, me and you should absolutely make an effort to do that. Okay, so I rest my case with how and why scientists should be presentable and professional. Okay, so I'm going to leave you with 3 C's of communications. I hope I convinced you that science communication in both writing format as well as with audiovisual format and oral format are important aspects of your training, and you should be getting trained continuously on that. And it comes with a practice. Planning, preparation, practice is the key to everything. You have to be consistent. You have to be consistent with your efforts. You have to be consistent with your style, formatting, layout. You also have to be consistent with how you manage your time while giving your talk. Don't go over time. If you're given 45 minutes, stay within that time, because then people respect you for that. Your slides should tell you a continuous story. So your science story should be cohesive. Here the idea is to simplify complex ideas that you have in your brain. You are the one who is working on that project. Not everybody knows all the tiny details of your projects. So your presentation should simplify and clarify for the audience. And of course, the idea is to convince everybody, but not in a crazy manner. And it's okay to make mistakes. It's okay to forget some of the guidelines that me and Jidnyasa gave you today. Maybe you will put in a lot of effort in planning, preparation, and practice, and still you will blank out while giving the presentation. It's all right if sometimes the pointer doesn't work. It's all right if things don't show up or the image didn't get projected properly. The idea is to adapt. Idea is to keep on working and not stop practicing what we have just shared with you. This is what we worked for us. May not work for everybody, but try to find your personal style of communicating science effectively, and you will be a great researcher. So with that, I'm going to hand over back to Vivek. Before that, I would like to thank the ISER Media Center for giving me and Jidnyasa this wonderful opportunity to give this talk, and we are open for questions. Thank you.
Thank you very much, Jidnyasa. It is so wonderful, Jidnyasa and Manasi. But Manasi, it was so wonderful listening to you. And as you mentioned in the presentation, exactly you followed what all things you have mentioned in the presentation as well. So it was so nice listening to you. In between, Anurag has shared all the questions, looking at all the repetition or whatever. He has shared on the chat. Are you able to access that?
Yes, yes.
Okay.
So what I'll do is I'll.
In between, I'm really sorry I didn't introduce Manasi. I'm really sorry, Manasi. I'm going to do that at the end. I'm really sorry for it. Manasi is a microbiologist by training, and she did her PhD from Wayne State University in the area of Drosophila and gene studies. At present, she is working with National Cancer Institute at NIH, where she studies about the DNA repair and gene stability. Other than that, she is a passionate science communicator. She wears multiple hats. She is into science communication as well, in depth. Sorry, yeah. I'm really so fascinated listening to both of you. I would like, it'll be great if we can have a workshop in the coming days where both of you together or individually presenting your as a course, as a short course on our website, where in future we can say that listen to the course first, then come back to the workshop where you interact with Manasi and Jidnyasa. Thank you very much for the presentation from both of you. Now the questions are open. We have put all the questions to Manasi and Jidnyasa. It is available in the chat list where it is curated by Anurag in the background, and it is available. I'll get back to.
So I will stop sharing my screen so that people can view us in a bigger screen.
Yes. Thank you.
Awesome. Okay.
Yeah. So I'll connect to Jidnyasa now. Would you like? How would you like to take it? Jidnyasa would like to take all the questions, then Manasi will take it.
Yeah.
Is that fine?
Sure.
Okay,
Yeah.
Great.
So
I'll connect back to Jidnyasa now.
Sure. I can ask questions to Jidnyasa.
Oh, great.
So that,
sure.
Yeah.
Please go ahead.
So Mrunal Kulkarni is asking, what does annotating an article mean? Can you elaborate, Jidnyasa?
Sure. So annotating article is basically highlighting the article. Usually it's a PDF format. So if you open the PDF, you will find on the top tools row, you can find the highlighting tool and select that and place it or select the text that you want to be highlighted. And you can actually highlight in different colors. So you can choose the color. It doesn't have to be always yellow. So you can choose the color and then highlight it. Maybe results in some color or other color. You can be creative with that. So that basically highlights annotation.
Okay. There's a next question. I'm paraphrasing it from Azim Khan. He's writing a review and he's not able to cite the references properly. So maybe can you explain how to make a reference sheet? So I think he is interested in understanding how to cite the references and link it to the article properly.
Yes. So Azim, actually, the referencing software that we talked about is the one that you are looking for. So when you are entering, so I would suggest you go and check how Zotero or Mendeley work. They have a word plugin that you need to install in your Word, Microsoft Word, and then that will show up as a tool on your toolbar, and then you can just uh, start typing in the first author name, if it, or the title of the article, it should pop up, and then you can do that. There are various YouTube videos available. You can check those out.
Right. Maybe we can add a link to one of the guidelines in our resource list so that they will have it handy. Okay, next question from Zil Anam. In what ways can we remember and organize a particular aspect for which we download the paper?
That's a very good and I would say that, of course, I always forget why did I download this paper.
Right.
So, a very good question. And as I told you, when you're naming the file, what you can do is in the end add a few keywords. No?
Yep.
It's for your own knowledge. Nobody is going to look at how to name the paper.
Right.
For the RT-PCR data. The background, paragraph 1, something, whatever is the you. And it does don't make it too long, then the files don't get But add up to 5 to 6 words and should be a good way to save the articles and also recollect why you saved the paper.
So one thing that generally people follow is a format of first author, last author, journal name, and the year of publication, that order. And then you can customize it with a keyword that Jidnyasa is talking about. So that when you search for, let's say, RT-PCR, all the titles containing RT-PCR word would show up as your search results in your folder. And then you can go through them one by one to identify which one you are looking into. She also has one more question. How can one... Okay, go ahead.
One more trick is to make subfolders.
Right.
All the articles related to one kind of can go in one subfolder. So you are, when you look at the articles related to that subject matter, you can just open that subfolder and you see all the articles.
There is a very great write-up piece that somebody just shared yesterday about how to organize your reference materials. And we will send a link out to all of you so that you will have that handy. That person has really done excellent job of organizing it. And I wish every one of us be that organized as that person, but I'm sure we all can learn to be better. Okay, so the same person already has asked one more question. So let's get to that first. How can one go about reading in the order to get hold of the literature review? So what should be the reading order? I feel that's what she's asking.
Or how
do you find relevant literature?
The best place to start is by reading a latest comprehensive review.
Right.
That will cite all the important publications that contributed to the knowledge in the field. And you can go to the original articles, read about how those experiments were done, what was exactly used as the material, what all the benefits. So to begin, review articles are a great gateway. Right. Right.
Yeah, and just to add to that, even if you're writing a review article, it's a great place to start by reading other review articles that came before your article. Because to be honest, 99% of the times you're going to write about the same topic again in a different journal for a different audience. Maybe you're just going to focus on subtopic of the big topic, but there is always pre-existing information out there for you to research and include in your own review. So it's a great start to read a review. Kiran Badwe is asking how to suggest reviewer for reviewing manuscript. Sometimes journals ask to suggest reviewers from within and outside country. So if I may go about this, this absolutely has to be in consultation with your professor or advisor or committee members. You don't make this decision on your own. It also depends on what is the focus point of your paper. So you need to have experts in that field to review your paper who will understand why this paper is significant, why this paper needs to be published. You also need to know, unfortunately, need to know who don't get along with your professor or with your lab, who are the people in the field who don't really believe your data for whatever reasons, and maybe don't suggest them as reviewers. You always have that option of excluding people from the list of reviewers when you are submitting to journals.
Especially, so there are labs who are working very closely on the same area or same question, and there might be a one-up race between the labs, and who publishes first gets the piece of the cake. So usually your competing labs or PIs are not preferred reviewers. So that, as I absolutely agree with Manasi, that has to be a call taken after consulting your advisor and your committee members or co-advisors you have. So yeah, don't go about answering that on
If someone copies from a video, how do they cite it?
You can always add a hyperlink to the video. That is, so when you look at the journal guidelines, they will have detailed instructions for how to cite a journal article, a review article, a book, a seminar, poster presentation or abstract that was published in a journal after, like, there is a abstract book that is published after some conference. So there is a way to cite each and every source document. So you can look up and find the instructions on how you can cite a video. So you can definitely add the hyperlink and any additional text that is just.
Another question about self-plagiarism. So the person already has written the paper, but now struggling to find words for their thesis, since most terms are the same. So how do we avoid self-plagiarism?
There are a couple of ways to go about it. You check with your university what are the types that the university considers as self-plagiarism. Usually, for a graduate student dissertation work, like, you can include your research papers as parts of your thesis. Not completely so, because of course when you're presenting or writing a manuscript, you are not going to elaborate on everything or include everything. So it's not going to be a copy of the research paper, but it would be majorly chunk of that chapter. However, checking with your university office, graduate office is a good idea. They can provide you with the specific guidelines that they would like you to follow. Like, for example, I remember for my PhD thesis, they just wanted me to include a sentence in the beginning of the chapter saying that this chapter has been previously published in such and such journal and citation.
Yeah.
And or parts of this chapter have been previously published. So of course, I had added material, like, for example, you wouldn't include negative data in your manuscript, but want to include part of it in your dissertation just to drive the point that why you shifted from point direction A to direction B. So in that case, it's not going to be completely self-plagiarism. So again, self-plagiarism will take a different meaning with the context. But absolutely do not want to copy paste from your own or your take it from your own lab into your actual. That is definitely
Right. Ankita Das is asking, introduction part should be whether it should be short or long in a review paper, and what is the difference between review and research article?
okay. So I'll take the second one first. So research article mainly focuses on describing new data that you have worked on, and review paper is summarizing what is the current status of research in the field. When you are trying to write a review article, your introduction, length of your introduction will depend on a couple of factors. One is basically all the journals will have some word limit for their publication. So if you want to fit your article in, say, 3,000 words, then you will see how much of the review article, like the content of actual review article is, what all points you're covering, and then your introduction will change, or the length of your introduction. Then it's not really the number of word count that matters, it's the message you want to convey. So I can talk about my research in 10 minutes, I can talk about it in 1 hour, right? So the same way you can describe the content in 1-2 paragraphs, or you can go about taking in 2 pages.
Yeah.
But a thumb rule is, if you can be crisp and brief, that is the best way to go about it. Don't unnecessarily increase the word count just because you have to have 3,000 words is the word limit. You don't have to have 3,000 words in your article. Your article could be just 2,000 words, and that's fine too, right? That's the upper limit.
Yeah, in between, I'm sorry to disturb this. We have lots of questions. So should we reduce taking number of questions?
I'm fine going over the time if
Okay.
people are still interested.
Okay, that we can.
I mean, if they're still watching it and they want their
yes, they are still watching.
questions answered.
Yeah, and definitely we want to get connected to your questions also, which comes much later. But please go ahead. Please go ahead. Please
okay.
Go ahead.
Okay, so next question is, basically people are asking what is the progress from draft 0 to draft 3. Can you share some examples? And yeah, go for it.
Okay, so draft 0 to draft 3, there is no thumb rule, or there is no standard where I should call this is draft 0, this is draft 1, and this is draft 3.
Yeah.
It's usually draft 0 to bullet point, where you're just kind of forming your basic structure of your manuscript. One will be where you will have complete sentences defining that. And from draft 1, say if you are just stating the key point in one complete sentence, draft 2 and draft 3, you are going to elaborate that sentence. So you are going to add a few more couple of sentences to each of the points that you are stating in draft. And ideally, editing can begin at draft 3 or draft 2. You need not be about editing much at draft 0 or draft 1.
Right. And that also applies to plagiarism, right? You can also, as you are editing, you should think about plagiarism, because somebody's asking what stage should we start checking for plagiarism?
No, I think start checking for plagiarism, basically start writing your paper that you are not plagiarizing. You know,
exactly.
Looking at a paper that I want to cite, and they have their results in 1, 2, 3 sentences. When I am citing their paper, I should not copy those sentences. If there is You don't need to rely on software to tell you whether you are plagiarizing or not. The important point to note here, and I think that is a distinction to make, is the plagiarism software is not going to uh, catch you if you cite particular reference and what you have written is probably similar to something else. You know? So long as you are citing whatever you are citing, you're not copy pasting from that source. Yeah. And I don't mean that you should copy paste from some other source, copy paste. But that is the idea that drives over the concept of plagiarism. Mm-hmm. Yeah, you should think about plagiarism. You should not worry about plagiarism if you are always writing your own sentences. In my
Can you specifically mention, let's say, 2 mistakes that everyone makes while making a manuscript? I can give you one. I always confuse between result and discussion.
Okay, good. Yeah. So I would say that result, you are very tempted to interpret your result in your result section. And if you can avoid that, then you have what you can call as a discussion. So I have this data where there is p-value of less than 0.05, which is significant. And then I want to tell why, what this means. But you have to state the data and the p-value in the results, but what it means in the discussion. So again, it's a very good distinction whether it's a result or a discussion point. Right?
Yeah.
Other, yeah.
Other thing, I think you already mentioned the other mistake, mixing methods and results. Right? That's the other mistake people do. Okay, let's go over to the next question. Do reviewers' comments come for review papers or is it only for research papers? They absolutely come for both.
Everything, yeah.
Everybody who submits anything to the journal comes back with a review.
If it's a peer-reviewed journal, then everything goes through peer review. Mm-hmm. For some pieces, the editor will be the peer reviewer, like letters to the editor are not going out to the peer. Right.
Yeah.
And but absolutely, any original article, any review article, it goes through peer.
People are asking about self-plagiarism check. If there are free softwares, I think we can send the links and details in the resource list. Let's go over next question. Are there any tools for American English suggestions, since commonly Indians tend to write in British English? So
you can set your language in Word. So Word, there is a facility or tool to set the language as English India, English British, UK English, American English. So if you choose English United States, then Word is going to take care of all the color versus COLOR versus UR sort of spelling errors. And then it's a acquired knowledge. There are very specific differences between American English and British English when it's compared. So more papers you read, that is also going to give you a better idea.
There are some words which are very specific to British English that we use. So when you want to say you combined things in one group, we tend to use a word called we club the data together. So if you use that sentence in an American context, people are going to think you're going to hit them, because club is something that you hit people with. And in British English, club is a place to gather together. So in Indian English, we use that in a context of we are gathering information or we are pulling together data together. So it's not to say that one is right and one is wrong. but you have to adhere to the scientific language and communication and rules. Should we cut on the use of articles if the word limit is crossed?
No. A big
no. That's right. Because articles are an essential part of every sentence. So if you take out the articles, things might change their meanings.
Yeah, totally they change the meaning. Never do that. There are other ways to like cut down your words. Using a hyphen, combine like a word phrase can cut down the words, and there are tricks of the trade. Basically, you cut down the fluff. This is when you edit very heavily. So you can reduce the word count without letting go of your precious art.
Paramita Sharma is asking, how many references should be used to write review paper?
That absolutely depends on the journal you choose. All journals will have a specific guideline for the number of references to include, and if they don't, even then, I would suggest that 100 to 150 is the maximum I have seen, and those are very like meta-analysis kind of reviews, very extensive reviews. So don't go overboard with that.
Can you mention quickly a course or two that somebody wants to take up if they want to go in science writing professionally after PhD?
Science writing, yeah, I will include links to a few Coursera courses. I also know that there are courses in India, at least one I know of, provide the certification, and I would try to use that thing. When you want to become a writer, your PhD papers and your thesis will also come very handy. That's what your work will be. So try to write or have at least one first author publication out of your PhD. One or two here, but at least one.
that you're not interested, or it's a completely tangential question, so I don't care about that question. Always be respectful and just acknowledge that it's a great question and you would need more time to answer.
I'm sorry to interrupt you. There was some
Sure.
technical glitch. The last
Okay.
question was not audible. I'm really sorry. It was something that happened from my end, not from your end. It was from my end.
Sure.
Something happened here. I'm really sorry.
Okay.
Please go ahead.
Do we want? Okay,
Yeah,
can
kindly
continue.
repeat the question. I'm sorry.
Continue.
All right.
Yeah.
Muskan has this question that how can I describe the processes I followed during my experiment and be bored them?
This is where you turning the science into story comes in the picture. The science that you do in the lab is not a very robotic thing, right? You come in the lab, you do the experiments, you troubleshoot them, you discuss things with your peers or lab mate who's on the next bench, right? So there is always a dialogue. Even though the experiment by itself is done with your hands and you're alone, it's mostly a team effort, right? So you already know what went on while you did the experiment. So include those details. When you're showing the graph, tell me what I'm looking at rather than just showing this is wild type, this is mutant. Wild type shows 10%, mutant shows 30%, so it is significant. Tell me what is that mutant. Tell me why that mutant is showing different phenotype or different percentage of your biological question than wild type. What could that mean? And maybe ask questions to the audience to engage them. It's also a great way to keep them engaged so that they don't get bored. If they know in first 15 minutes that the speaker is probably going to ask them in between about whether they are following the question, what they're talking, whether they are, whether they missed something and the speaker is ready to explain it again, clarify it again, they will be more receptive to the presentation.
Also, I think I will add here that you, as Manasi has mentioned, you have to cater to your audience. So if your audience is somebody who's already working in the field, you may not need to go in very high details of how you did the experiment. They are probably more interested in what results you have, what is your data saying or telling the story. So you need not explain how you perform the experiment if your audience is from the field. Okay.
Excellent point, Jidnyasa. I always consider lab meetings as daily TV soaps. Everybody is following the story properly already. Everybody knows who's the hero, the heroine, the main character, all the saga that's happening. So they don't really need a recap of that. So I can only tell them what's important for that lab meeting. But if I'm presenting in a conference, I need to give that recap. Then it's more like a documentary that I'm watching. I need some background information to understand what is the significance of this work. Why should I be interested in this work? Then go into details of your work and then end your story with a take-home message. So think about your story in forms of, let's say, a daily soap versus a movie versus a documentary versus a music video or something like that. Some analogy so that you can think about what works in those different formats for your science talks.
Moving to next question from Parinita.
Mm-hmm.
Sometimes we have to suddenly reduce the length of your talk, and how can you manage that? How do you manage?
Again, great question. And it's always possible to go over time. Sometimes you tend to explain things in much more detail than what you have practiced for, and then it takes time. The main idea is to think about what are the key points that you absolutely want your audience to remember. And then if you want to reduce your talk, maybe don't give them 4 more data pieces. Summarize those data pieces into a text or a verbal format by saying, so I don't have much time to go into details of these experiments, but the gist of it is, and this is the result. and then move on to the next point, so that you don't compromise the story, you don't compromise the work that you have done, the efforts that you have put in, but explain it in a shorter format, and that will take lesser time, and then you can go on to or move on to the next session. Sometimes it works if you repeatedly practice your talk. So it, you know, some slides are automatically recited without you thinking about them, and then that saves you a lot of time. If you have transition slides, they come in very handy when you have to reduce the talk length, because then the transition will give you an opportunity to explain it a bit more rather than actually showing the data which follows the transition slide, and then you can skip those slides and then go on to the next transition slide. So those are the tricks that I generally use if I'm going over time, which I actually used in today's presentation.
I didn't know. Yeah. So the next question is from Anam. And when we are presenting, should we put one result or one aspect per slide, like proving same things using different texts? I think yes.
I think yes, but more than showing the same data with three different techniques, if you are in a time crunch, I won't show three different techniques. I will tell them that I did this experiment using different techniques, but I am showing you this one key significant result from whichever technique that is the most telling of your story. So you don't have to have all three Western blots, all three qPCR results, all three gels in your presentation if only one Western blot is going to show the same result. So think about the key piece of data, describe that, put time and effort in explaining that well, and then you won't need other supporting data materials much.
The next question is from Pritha, and he is asking about the headline or heading of the slide and how specific those titles and headlines can be, and how big or small. I think he said that twice.
Let's think about specificity. They absolutely have to be specific. As I said, they can't be general as writing conclusion 1, conclusion 2, result 1, data 2. They absolutely have to have meaning. They absolutely have to be descriptive of what you're showing on that slide. So if you're showing something that projects a negative data, even though it's a negative data, your title should suggest that. It should suggest that it indicates or it suggests that this is not true, or something to that effect. How big or how small it should be, it depends on what type of presentation you're doing. When you are doing a PowerPoint presentation, generally people tend to limit font sizes to 40 for headings. Anything more than that, and then you're going to occupy half of your slide with your title. And then you're going to left with very tiny text size if you're putting text in the subheadings. So find a balance. I generally like to use 32 or 36 sometimes if the heading is a small sentence. And then for the text below, I generally use somewhere between 22 to 26 as my text size. But it's just what works for me. It's not a standard rule for everyone to follow. Also, if it's a poster, you have to think about how is it visible. General rule is title should be visible from 4 feet away. The text should be at least legible and visible from a feet or feet and a half of a distance for poster. Nobody is going to come very close to the poster and read it, right? So it has to be visible and legible from a quite distance. So you have to think about font choice and color choice from that angle also.
Also, 2-point poster, you have to also take into consideration the dimensions that you need to fit the text in. And for posters, when you're designing it in, say, a PowerPoint, when you want to have a feel of how it will look in the print without printing it actually, then you put the PowerPoint magnification to 100%. And then you can just back off from your computer or laptop and check how far you can go and still read that text.
Right. Or you make a full screen, make it in a presenter mode and go back a feet or two and look at it. And can you sort of understand what's going on? And that's the idea. It also works with your PowerPoint presentation layouts. Thumb rule of whether your slides are proper, they are not wordy, cluttered, is changing your PowerPoint slides to a thumbnail format. So that means the screen gets divided into two columns, and one column is your actual window where your cursor is, and then on the left column you have these tiny tiles of each of the slides in your presentation. And make it so that your tile size is, let's say, 2 centimeter by 2 centimeter. Every slide should be somewhere around 2 centimeter by 2 centimeter. And then see if you can still understand what's going on each slide. If you can sort of gather an idea of, okay, let's say at that thumbnail view, I can get that the first slide is a title, the second slide is where the science cover story was, and then the third slide was where the mapping my story came in, I'm doing a great job. If I can't get any sense out of that format, that's probably the time you want to go back and change the layout so that it's visible, legible, and understandable in the thumbnail format. So that works always.
Okay, can you hear me well, Manasi?
Yes.
The next question is, what do you mean by web safe color with 130?
Okay, great question. Again, it's a built-in feature for PowerPoint presentations. When you are selecting font colors, they always give you an option of more colors in that color wheel. Click on that, and on that panel, you will have this bottom down or pull down pointer, which will give you option of choosing web safe color. What I mean by that is, if you use that color and then put your presentation on a projector or a digital screen like how we are sharing today, the font color doesn't change, doesn't bleed. It doesn't turn into some different shade that gets dissolved in the background. It also means that there are automatic color visibility softwares that are used by blind people that computer can work around and tell that, okay, the slide is in a black background with a yellow color. And if your color choices are not web safe, then those softwares don't pick out those color differences. It's also important to consider that 1 in 100 people on an average have some sort of a color blindness issue in this world. So it's very hard for them to differentiate color schemes of green and red. So web safe colors are one of the tools that you can use to make your talk accessible to everybody. So you can of course find them in PowerPoint, and also just Google them, web safe color palettes, and use them.
Great. So next question Prita has is it always necessary to put the reference or citation in the slide where we are keeping an image, or the picture copied directly from the paper?
To start with, I would say just keep your reference on the slide itself where you're actually depicting the picture. It's important because sometimes you tend to get, let's say you're doing a journal club, then you are only focusing on one piece of article. Then you don't need to have citation for the same article on every slide. But let's say my presentation, I had used all these symbols and graphics that came from different outlets. And if it is making your slide look cluttered, by all means, give the references and citations at the end. But I think the most appropriate part of this is to cite. It doesn't matter whether you cite it on every slide or at the end of your presentation. Acknowledgement is the most important thing.
Agreed. Yeah. So next is Surojit is asking, is abstract is necessary thing to put in the post?
Absolutely not. It's an optional thing. Abstract just helps you to tell your story better. In case you have to hurry and explain your story in, let's say, a minute, rather than going through the details, somebody can read an abstract and get an idea. That's the only purpose abstract is there on the poster. With the graphical abstract being used more and more, text abstract can be replaced with graphical abstracts. And as I said, picture which speaks 1,000 words, and pictures are much more easier to understand and engaging. So if you can make graphical abstract, I would prefer that on the posters. And in general, posters are always more text intensive. So anything to break that text intensive flow and make it more image friendly will be helpful. So include more figures, include more charts, include more data points and just few keywords, few sentences.
Yeah, keep the text to the minimum.
Yes.
Pritha's next question, I'm not taking. I think you answered it.
Yeah, we already answered.
Optimum font size.
Mm-hmm.
Then tips and tricks for presenting a PowerPoint online through screen sharing and audio. That's the next question Abrani has.
So I think it will be a lengthy answer. The quick answer to that is you can always Google for whatever platform you're sharing your content with. So let's say you are sharing PowerPoint slide using Google Meet. You can literally ask Google to tell you exactly how to do it, what are the effective ways to do it, or what not to do. One thing to do is maybe have a backup of all your slides in a PDF format, so that if your PowerPoint presentation somehow doesn't work, then your PDF will be a non-losable and very crisp version of the same slides. The only caveat to that statement is that you have to have all your content on the slide on non-overlapping format. So let's say your animations are designed in such a way that at the end of the slide, 3 things pile up on each other. Then when you convert your PowerPoint presentations in the PDF slide deck, all those pile ups will be evident and all the data will be on top of each other and it will be mixed. So make sure that you use animation very, very carefully. Make sure when you are converting your slides to PDFs that all the data is projected properly before you actually project it on the screen.
Okay. So I think this is for me, Ankita's question. I'll just take it.
Go ahead.
Sit later. While writing a review, should I cite the oldest work or the recent one or both?
Mm-hmm.
Depends on what you are citing. Like what is the citation for? So whatever you're writing, whether so I'm not really clear what you mean by oldest work. Probably the original reference. So
yes,
it is going way beyond 20 years or more, then I would just a review for that.
That's right.
It's not a fixed timeline, but yeah, 20 years is a pretty long time in science. So then that becomes old work, and you can cite a review for that. But for recent discoveries, something in last 10 years or before 20 years, so make sure you are citing the original one, rather than recent. The next question Rachel has for you, Manasi, is if there are any good softwares or apps for creating graphical abstracts? If there are any.
There are definitely softwares and apps that can help you do the graphical abstract. I'm going to send some of the links. Of course, they are partially paid. So try to use them in the free edition, get some basic training from those sites, and then you're on your own. There are some crowdsourcing platforms where the graphical abstracts and images and logos and icons have been posted in some sort of a database and they are freely available. So we will also send you links for that. One of the things that I used for today's presentation is called the Noun Project. It's a repository of thousands of STEM related icons or logos or images, and you can you have an option of customizing it if you are a paid member, or you have an option of freely downloading it for the Creative Commons use, not in your paper without copywriting or without taking permissions from them. So make sure that you follow the guidelines, read properly what are the rules of using those websites for your work.
Next question I'm going to skip from Anudeep because you already answered when you mentioned the references for figures we use in presentation.
I think we've covered everything.
Tourism we have covered.
Okay, the last question is, when we go for a publication, how should we weigh impact factor versus citation index of a journal? Which is more important? And what is SJR in Scopus? You might be more, take
So I do not know what is SJR in Scopus. I will have to read on that. But weighing impact factor versus citation index, see, both are some sort of tool that gives you an idea of the citation. Impact factor in the end is also a citation index. So there are other heat indexes, multiple indexes used in the field. What is more important while choosing a journal is weighing the importance of your story against what is being published in that journal. So some results are breakthrough results, and then they will be entertained by journals like Cell, Science, Nature. But then if you're following up on that true result, your results are going deeper into that new discovery, so to say, then that follow-up publication is not going to get as much traction. Then there are usually the tiers in the journals. So there will be tier 1 journals, tier 2 journals, and so on. So depending on the impact factor. So try to find where your story lies and what tier your story lies. And it would be a good idea to hit that tier of journals for your publication rather than trying out a very expensive or high index journal and getting a rejection. You have to take into consideration the timelines for publishing a paper. It takes at least 3 to 4 months to complete publication from the submission of your manuscript. The journals are trying to reduce that time, but it is the time that goes into peer review, getting the comments back, addressing those, galley proofs, etc. Oh, there was a question for galley proofs that I saw. Galley proofs are basically the pre-publishing ready versions of your paper. So when you write in Word, you are writing in one single column, right? When you see a journal article, it is usually broken up into smaller columns. So when you do that, your words may break up at random places. So you have to put a non-breaking space for some words to not break up. So all those things will come into picture when you are doing when you are checking your galley. And then again, printing mistakes happen. So data errors, all those. So for that you need galley. So coming back to journal publication, so make sure you are hitting the right tier of journal when you're choosing your journal. Be wise. You want to reach out to the audience rather than having that impact. And there are stories in the field where very, very key discoveries have been turned down by Science and Nature and got published in some next year journal, and then they have the citations that they deserve. So if your story is going to sell through, it is going to gain citations along the way. So it's your individual index that matters rather than which index of the site.
Sounds good. I think we've covered all the questions.
Yes. Vivek, sir.
Back to you, Vivek.
Yes. One second.
it's so
Great.
wonderful.
Thank you so much.
Interacting with the audience, and you have spent a lot of time. You have, more than 45 minutes for them. I'm really thankful to you for taking it up in such a sportive spirit.
Yeah, it's our pleasure to interact and to give this talk.
Yes.
Yes,
We hope
absolutely.
that everybody has found something new to take
Yes.
away.
Yeah.
I'm very sure about it. And I have to thank you for being so patient enough to spend such amount of time. And this is how, this is in Kerala, it is called Ramayana Masa at this time. And towards the end of his life, he wanted to thank Hanuma. He wanted to thank, but he couldn't thank, because if you thank somebody, it should be like this: if something happened to you, I will help you. So if something should happen to them to help, but in your case, it's so wonderful having interacting with you, with the audience, and it is so nice. And I would like to again mention both the project training program enabling science communication by Department of Science and Technology under by NCSTC under DST, and along with ISA Pune Science Media Center, and the coordinators for the center, Arna Mukherjee, and coordinator to the project, Haruna Chakrapani, and people who are behind the scene, but they were not visible, but they were the key people to run this program. One is Suchiprata Bora and Anurag Shukla behind the technical aspects of it, and all communication with both Jidnyasa and Manasi, and Imayavan for setting up the camera and other facility here. And thank you so
Thank
much
you.
for the audience also for being all around the globe. They all spend their time here with us for the event. Thank you very much. I'm going
Thank
back to
you.
the.
Thanks.
Thank you.